Hey, evening. Yes, so I learned a lot in my IoT course. I will just highlight a few things that I learned, and then we call it a day. Yes, so okay, we learned a lot. We did the C++, the C language, embedded C. We did the Arduino, and we did the Blink app. But for me, because of time, we are going to start with Internet of Things. So Internet of Things definition is that Internet of Things is okay. Once we come to Internet of Things, it is the network of physical objects that contain embedded technology to communicate and interact with their internal states or external environment. That just simply means that we have small objects, very minute objects, are connected to the cloud, and then once it's connected to the cloud, we get the solution from the cloud, and then from the other end, the user gets to know or gets the solution from the other end. That means an engineer comes, spots an opportunity or a problem, and then develops a small electronic device, which then it's connected to the internet, or it's connected to the cloud. Once it's connected to the cloud, it sends its signals there, and then in the cloud we got the solution. So after that data or those signals are processed, they give out an adequate information. Yes, so that is just generally what Internet of Things is, and it has advantages and disadvantages. So advantages of IoT is that the hardware of developing these small objects, these small devices, it's becoming cheap. The connectivity is becoming wide, and the software, it's becoming more advanced. Like the softwares that were developed back then, they are not the same as those ones that are developed now, that can communicate, or that can actually send signal, that can actually get send signals from a small device to the cloud, and then the cloud cost is becoming less and less cheap and more flexible, because the more the devices, the more we go the devices, the less the cost of hiring those clouds servers. Yes, disadvantages is that we got addressing that kind of there is also connectivity, there is scale, there is data volume. Internet of Things works with big data volumes, and then the device size. The device ideally it should be very, very small depending on the needs. Yeah, like you see those trackers, like those pet trackers, human trackers, you see how small they are. That's how it should be. Yes, so we go next to the architecture of Internet of Things. So as we are saying that for IoT to work, we must have a device that is connected to the internet, and then once the device is connected to the internet, it is able to communicate to the internet for data processing and analytics, and then after the data is processed, we get the feedback in terms of presentation. Yes, for instance, here you can see we got IP cable devices. Let's say maybe it's a car track. It gets connected to the car, and then it is connected to the cloud, which is gateway, and once it is connected to the cloud, it is able to send the signals, the GPS signals, to this cloud using maybe to the Google Map, those kind of stuff. And then in the internet, the Google Map, for instance, it says it shows the where the device is, and then sends it to the where the presentation is. So the device here, let's say an IP capable device, it's connected to the internet, and then it sends the data to the internet, to the cloud, and then once it is in the cloud, the data is processed. After the data is processed, it is given back to the user interface as a solution. Yes, so that is part of the architecture of it. We have the existing IoT devices, we have the low power devices. You see, these devices, or the device that should be connected, they should be able to communicate to the internet. They should be existing actually. Yeah, so see, it's not an imaginable device, and then they should be low powered, meaning that you don't have to carry a big battery to connect a small device. Yes, so I think we are through with this. There is something else that we learned about the embedded systems, and embedded systems are any combination of hardware or software which is intended to do a specific task. That's what they are called. They are embedded systems. Like you see, they can be called as embedded systems. Let's say, like, let's talk of a car track or a CCTV. A CCTV is made up of the hardware and the software part of it. The hardware is cameras and the like, and then the software is that those instructions that enable the CCTV to send those images, to store them, to set them to maybe the visual display. Yeah, those are embedded systems. And we got a lot of we got categories of them, like standalone. We have real time, we have networked, we have the mobile. Standalone, let's say it doesn't need any other device. It's not connected to internet or any other device for it to function. An example is just let's say a microwave, or a washer machine. And then we have the real time, we have the networked, like laptops, we have the mobile, like the mobile phones. And we can see the components of them. The components of embedded systems, we have the software, in the software it's divided into we have the software, then we have the actuators, and then we have the sensors, and then we have the auxiliary systems like power, cooling systems. And into it, let's say the actuator is connected to DAC, and then the DAC is connected to UC or COC or UP, and then to the memory. Okay, it starts like the UC is connected to DAC, and then the DAC is connected to the actuator, and then the memory is connected to UC, and the data can move from the memory to the UC and the vice versa. The same with the sensors, and the same with let's say human interfaces, the holistic ports, auxiliary systems. Yes, so I think that's an overview of it. And then we got the Arduino. We got the two parts of Arduino. We have the software part of it, and then we have the Arduino board. Here we can see the interface we can see these presentations of PWM or PMW, which is pass modulation. These ones are used for motors, servo motors, and the like. So they are just used to give. They are just a technique used to vary active time versus inactive time in a fixed period. Yeah. So these PMs are found in the Arduino. They are part of electronics. There are different parts of Arduino. but for me, because my project is actually based on PWM, that's why I'm just trying to come up with this presentation in terms of PMW. Yes, and mostly used to control the average voltage load of the connected devices. The PMWs are used to control the average voltage of the load connected to the electronics, to the device. They are mostly used in motor controls, lamp dimmers, audio, power controls, and many more. Yes, I think we are good with that. So we have part of Arduino in terms of communication, and that's where the Blink comes. So the Blink is an app that is free. Okay, it's not that free, but it's cheaper. You can actually code, set signals online. You don't need to have literally to have the hardware part of it literally in order to come up with a solution in the cloud. So use Blink app. Yes. So I think this is that's a part of introduction of what we learned. That is just an overview of what we learned, and now we should go to the application part of it. Yes. So for Arduino, as I said, we have the software part of it, which is this